Good morning, ladies and gentlemen of Precalculus. Welcome in room 15, where?
Learning never ends.
Learning never stops.
Learning never stops.
Okay, very good. Good, we got the picture. All right. Yesterday, we talked a little bit about logarithms and exponents, kind of the relations between them, kind of making up for what we didn't quite get to last year. Today, we're going to go ahead and go into something called circles. And you guys know what circles are, right?
It's a round thing.
A round
Like
thing,
this.
right? And what happens is, I'm going to give you a general form for the equation of a circle, and then we're going to kind of give some examples of that. And then by the end of class, it probably won't take the whole class period, so we're going to start on the next thing today too. So here, what you have for a circle, the general form for that is you have x minus h squared plus quantity y minus k squared equals r squared.
Wait, Mr. K, can I interrupt for a second?
Yes, ma'am, yes.
This year, are we going to get to use our notes on our test again?
Probably, yeah, I think probably do that.
Okay.
Good question.
I think it's a good idea.
Yeah.
Yeah, good question. Yeah, keeps you organized on that. And so now, do we remember what the h and the k do?
The
Up
K is
and down.
horizontal, or no. The
K's up and down.
K is
H
vertical, the H
left
is
or right.
horizontal.
Yeah, so horizontal, translation, I'll call it. And this right here is going to be vertical translation.
Isn't the R radius?
Yes, R equals radius.
For like geeks.
Okay, so we're going to go ahead and I want to go ahead and put an equation up here, and we're just going to graph it. I'm going to fill in numbers for these things. Is everybody okay on this so far? So, in Crandall last year, Sierra, did you do this? You didn't? Charlie, you didn't do it? Okay. All right, so you guys didn't get to it either. We didn't quite. Okay? I'm going to give an example here. And it's going to be, we're going to have x minus 2 squared plus, we'll have y plus 3 squared equals 25. And we're going to go ahead and graph this.
Right, then you
We'll go ahead and graph this, okay? So let's go ahead and get the thing. So this circle, where is the center going to be? The center is going to be located where? What is the coordinate pair that represents the center of this circle?
-2.
2, -3.
Yeah, so what it is, it's actually going to be this 2, -3. And what it is, because the standard form here is going to be x minus h and y minus k. And so the center is going to be the coordinate pair h, comma k. And in this case, as Caden says, you're going to have a positive 2, but here for y plus 3, you have y minus -3. And so that's why the center is going to be located with that coordinate pair. Okay? So just watch out for that. And what is the radius of this thing going to be?
5.
Radius is going to be 5 because 25 is equal to r squared. So therefore your radius is going to be 5. So then we can sketch a graph of this. So I'll just do this pretty quickly here. So I got the 2, -3. So here's the 2, and here's the -3, So here's our center right here. And then we're kind of going to get off the page here. So it's going to be a radius of 5, so it'll be up here. And then over here, it's going to be something like this, right? And it's kind of off the page here, but you get the idea, right? Now, it so happens, I want to show you on your calculator where there is such a thing. And I don't want to make this a calculator demonstration today. But do you have any questions on this one so far? Okay, let's go. I want to go to a calculator here. And in the calculator, I tried to arm all the calculators with this last year. And so you may not, and a lot of you have your own calculator. But if you go to the apps right here, there's a conics app, which is 4, and you have different options for the different 4 types of conics. And if you go to enter circle, you get these different formats, and you can use either one of these, but the one that's better to use, and the way I explained it here, was this one right here, right? So if you press enter, you get this thing, and you get H is K, so what Caden said was right. So we take 2, and K was -3, and R is 5. What is that going to look like? Well, we graph it, and it's going to look like this, which is pretty much the way I sketched it, right? So that's something that's going to be available to you on your calculator. And if you don't have that app on your calculator, I can go ahead and put it on there for you.
Mr. G, you know we have calculators like on our phones that look just like this.
Yeah, you can. There are, yeah.
I have it.
There are. In fact, that
I use it
reminds
all the
me,
time.
I haven't updated mine with that too. Oh no, I think I did, because I think it automatically will. I have to look at that calculator. Okay, very good. It used to be for the longest time they didn't have one that was for iOS, but now they do have one for iOS. Let's see here. Escape, here we go. There we go. So I'm out of the app. Okay, so there's that one. And so you have questions about that. Okay, I'm going to go over one. I'm just saving this for fourth period. Okay, I'm going to write down a problem here for you.
Carly, you want to collect in, right?
And we're going to kind of work it out here. So here we have this problem, and I have it written down here. So let's say we have an equation here, x squared minus 6x plus y squared plus 4y.
Oh, that's your radius now.
Okay, so we have this is the equation of a circle. It doesn't look much like an equation of a circle, but it really is.
Okay.
What tells you it's an equation of a circle?
Y.
Hart, what tells you it's an equation of a circle?
Go ahead, Charlie.
Anybody?
You have an X and a Y.
Okay,
The
x
way
and
it's set
y,
up.
but more
Y equals
specifically an x and a y, what is it?
I said the way it's set up. It's like
Equals
this.
slope.
Okay, Caden said we have an x and a y, but it could be like,
Ashton, do you have any input?
if I had just -6, another equation, if I put -6x plus 4y equals 3, this is an example. This is an example of an equation that has an x and a y, but this one over here on the right is not a circle. This is a linear one. How do we know this is a circle, but this one here is linear? They both have x. Yeah, you have to have an x squared and a y squared, and they have to be plus each other, right? So x, you have to have an x squared and a y squared, and it has to be plus, each of those plus, right? So that's how you know it's a circle. Okay, what are you going to do to put this in standard form, to get this in form like this, like this? What do we have to do to this equation here to get it to look like this, so we can sketch what the graph of that's like?
Square root it.
Okay? Techniques, anybody can think of what to do?
Oh,
Okay, I want
combine your
when I-
like terms.
you would look for that, Charlie. That's right,
Charlie.
but there are no
There
like
are no
terms
like
there.
There are no.
No, but I'm glad you thought. But that was a good thought to have, right? So he asked a good question, even though,
It was completely wrong.
well, it wasn't. No, it was a necessary question, because you should ask that question, right? So I give credit for asking the question. Okay. So what we're going to do here is we're going to go ahead. Anybody have an idea on this? Okay. Okay. What we're going to do is we're going to take this x squared minus 6x, and then I'm going to put plus and a blank over here, and then I'm going to put plus.
Is this Hoffman square?
Okay, yeah, so Caden, I think Caden is on to something here. I don't know if in Crandall, did you guys do Hoffman Square in Crandall? You probably did.
No, we didn't.
I'll tell you who I got Hoffman Square from. The lady who did the video, the long packet video, she was the one who came up with Hoffman
Oh,
Square.
your friend?
Yeah, my friend, yeah. Yeah, so that was her Dr. Hoffman Square, right? So anyway, okay, Charlie, 2 and Sierra, do you remember doing this last year?
No.
Oh,
I
there's
know.
two here.
Okay, you don't remember doing this last year? Okay. So what do we do on this one? I think Caden, by what he said, might remember what it is.
I thought that's who he was talking to. Sierra.
You know what to do on this, Caden.
I
Oh
don't.
yeah, Caden knows what to do.
He remembered.
I know,
Why
I know
don't we
the
ask-
idea
why
of
don't we
Hoffman
ask
square, but
Ashton?
that's a little rusty.
Ashton
Ashton
knows.
Ashton knows.
Ashton knows.
Ashton
Ashton.
always knows.
Gimme.
Or Bryce.
Okay, but he remembered Dr. Hoffman Square. Okay.
Yeah, I remember Hoffman
So
square.
I got to give him credit for that. So you take half. What's going to be half of -6? Equals
-3.
-3. And -3 squared is equals 9. So 9 is going to go here. And if we add 9 over here, what do we have to do on the right side?
Add 9.
We have to add 9. Okay? And so now we're going to do Dr. Hoffman square with this 4. So what's going to be 4 divided by 2?
2.
2. And what's 2 squared?
4.
4. So what do we have to add here? 4. What do we have to add over here?
4.
4. So let's go ahead and so now we're ready to write it. So now, and what do we have on the right side here? 3, 16? So we know the radius of the circle already, don't we? What's our radius of our circle?
4.
Radius is 4. Okay, good.
So
So here we have x and y. So it's going to be x what? X minus or x plus?
X minus.
X
Plus.
minus, x minus,
9.
no,
6.
no,
No. 3.
x minus 3. See, there you are, there's a 3. And it's going to be y plus 2. So we have 3, so we have HK is going to be 3 minus 2, right? So we have that,
We could have.
okay? So that's going to be our center. So 3, -2, it's going to be pretty close to that last one we did. So you have 3, -2. So 1, 2, 3, and -2. And we have our radius of 4. And so it's going to be, something that looks like this.
Like actual work.
No,
Okay.
watch videos. And how to like answer case.
But no paper. No paper.
Okay, do you want me to give you another one, see if you,
Hold on, I'm still doing this one, Mr. G.
I think this one's
Yeah.
pretty good.
I think I learned.
I think I want to give you one more to
Everything on
try to do, except I don't have the radius worked out for you. Question, anybody have a question on this? Yes, Sierra.
I know, I can just skip it out.
Okay, Sierra has a good question about the graphing, right? The center of the circle is determined by the coordinate pair h and k, h comma k. And here you have h, it's going to be x minus h, so 3 is going to be positive for your x coordinate. Then you have y plus 2, and it's going to be y minus negative 2. So it's like the sign goes opposite in the way it works out. So that's how I know the center is there. Okay, so you get familiar with it. And we did a little bit of completing the square in this class in Algebra 2 Honor. You remember that last year, because you remember Dr. Hoffman's square. You guys remember this, right? Most
Yes.
of you, at least somewhat.
Yes.
And so what I propose to do is I'll just make another example problem out here, and just have you work it. I'm not going to have the radius worked out as much, so we might get kind of a square root of a radius, because I don't have it worked out as neatly. But let's go ahead and do that. Okay.
And they're very flexible.
Then how did you get, wait, how did you get 416? Yeah, 5/4.
Yeah, because R squared.
Okay, x squared plus y squared
216.
plus 10y
I'll walk this time.
minus
Okay, Mr. G, can you go a little bit slower this time?
12x
And pay attention.
equals 1. So just work on that one here. We'll go over it in, how much time will you need to do this? 5 minutes? 4 minutes? Something like that? So Sierra, do you have an idea of what to do on this one? Kind of, okay.
I don't. I get it a little.
This year it doesn't.
You don't
No.
see what's going on here yet? But do you remember doing the completing the square last year? You should remember that a little bit, you don't?
Somewhat. Should remember it.
Yeah, so Algebra 2, the where do I start my line? It was Algebra 1 has been so long. Well, you realize it could be Algebra 2 has been so long, right?
Yeah.
Yeah, that's true. I grant you that.
Wait, what'd you put?
What is negative 6?
Why are you putting dot dot dot?
That's Hoffman's square.
What is
Oh, okay,
negative 6
so wait,
squared?
what'd you put? 1x squared? So we put? Yeah. Okay. What do you put for the first one?
X squared.
Okay.
So you get your x's in parentheses and your y's in parentheses.
Yeah, you try to find the radius. The radius is going to be,
Minus 12x?
because what you're going to have is you're going to have a number on the right side,
Oh, I didn't even dot dot dot.
and the radius is the square root of whatever that number on the right side is.
Need dot 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 again?
36.
Dot 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 dot.
Then what? Then you take this number, this number.
Does it matter which one of your y's go first?
What do you mean?
Like,
Did anybody get,
if I put 10y.
I try to do them
Mr. G, will you come see if this is right?
just before you do this.
This?
Did anybody get as a radius square root of 62?
Get your answer.
You got a square root of 62 as a radius?
Negative 12 divided by 2.
Okay, good.
Negative 6.
Correct.
Negative 6 squared.
Yeah, equals 62, so that's
So
where square root
this
of
is
62
right?
is.
Whole thing's right.
See here. Is that minus 6?
Minus 3.
I think that's right.
And then
It's
plus
that
5.
same thing over there.
And then y, it'll be y plus 5 squared, x minus 6
Equals
equals 62.
5 squared.
Yes, I got it
You got it
right. I did.
You're just like a circle connected genius.
Yes, I am SUG.
All right. We got a circle genius.
You
We
combine
get
your-
62.
Because you add 36, 25, and 1.
Okay, were you the first one to get it right? Who was?
I think so. She was. She deserves a star for that.
Mr. G, can I go work
Well,
some?
I was.
You want to work it?
Yes. For extra credit.
So are you ready to do it now?
Almost. Give me just a second.
So then, once you get those, and that's
Here
your
you are,
two.
cool.
I always start with X.
You bring your x down, let's see for your x. And then you're gonna take this number, this one goes down. So the middle. And then same thing on your y's, take your 5.
So Y plus 5? Okay.
Those are squared. And you add it, you're adding. Square on that one.
25.
And then that you just square that to get your radius. That's pretty sharp.
Okay, so I'll square this.
Or not square, you square root it.
Mr. G, all I need is the square root of 62 and I'm done.
Yeah, so that's your
I
radius.
just don't have my calculator.
You don't need a calculator, it's just your radius is square root of 62.
There's like, not a good.
Okay. Can I work it?
Yeah, you work. So it's gonna be a little less than 8, right? Yeah, go ahead.
Yeah, a little bit less than 8. The marker's like back here somewhere?
Yeah.
Oh my gosh, I actually would be able to do this. I'm trying.
Let me take this out so I can stay. Yeah. Okay. What do you have that ready? Type on the computer. Oh, wow, let me see terrible writing this.
So Sierra, are you figuring it out on this one?
I'm trying.
You doing okay? Are you having some remembrance of last year on this a little bit?
No, I'm not making
We did it with parabolas, is what we did it with last year. When we had the completing the square. We had one of the problems was a volleyball. One was an acrobat that was tossing a pin or something like that. It came down. And one was a volleyball.
I might have been sick. I don't remember. I would try more than I would ever.
I was like, this is a lot. She told me it was me and I just stormed off. We were like, Tends to reverse flip. These are the worst things I've ever done. I can't. My finger. I'm so dumb.
It's the thing where you do the pull up and your knees are on the little plate that goes up with you.
Yeah, because.
You know what I'm talking about? You know what I'm talking about, yeah.
Even reverse forward.
I would see and your knees are
We haven't done it.
Wait, but y'all have you ever done that?
No.
Okay, well, that's the shortest thing I've done. Even the bar, on the lowest thing, like, you bridge it, and then you lay on the ground, and you pull yourself
I'm
up.
just the bottom of the desk.
It's so stupid. I hate it. Then I used to like funky with the color.
That happened like
It's a
3
gym
days in a row. I was like, are you
Like you.
Good. Exactly what you guys about that.
All right, thank you. Okay, thank you, Charlie. So So right now, your this right here, radius equals square root of 62, right? And then what's the center?
That's like you were there.
Center should be at okay. Are we okay on this? Okay. And we're gonna go ahead and do things. I hope we get time to go to ellipses and hyperbolas this year too. But that's just sort
What
of
is ellipses and hyperbolas?
what are ellipses and hyperbolas?
I thought a hyperbole was like an exaggeration.
Yeah, it's a hyperbole, but I'm talking about hyperbola.
Oh.
Yeah, they're different.
Hyperbola.
So what an ellipse
Yeah, exaggeration.
Have you seen that thing?
it's this kind of shape here. It's an oval shape, and it's the most prevalent shape in the universe because it's the orbit of all our planets and galaxies and all that. So that's an ellipse. And nothing in nature is actually a perfect circle. So if you elongate, like even the orbits, they look circular, but they're actually elliptical
I can't believe
because
it.
they're not perfectly round.
And
And then a hyperbola,
So proud of myself.
a hyperbola
I can do it.
I
is
feel like I know.
is like this.
Wow.
For the first time, like 2 years.
It looks kind of like a parabola, sort of. That's a hyperbola. We'll be going over those a
So
little.
good about myself.
So and so you can have a hyperbola that looks like this,
CPA
or we can have one that looks,
CPA.
Jack is EPA.
well,
It's your accountant.
we have one that looks,
Thing.
it comes like horizontally like this.
Yeah.
So they're like, almost like little parabolas. Okay.
They're usually like,
I had to pay 180.
yeah, like 180 for
But I also had $200 discount and $60 discount, so it's like 400. Because I took classes before and TVCC gave us a discount.
Sometimes they like send you back something. Like this summer, I got a check for like $47.
Yeah, mine was $80.
I think you get like one class free.
Okay.
Which one's not me?
Last year was all free though. Because
Last
they
year
paid
they
for
just
everything.
send you money back. Like,
All right, so what we're going to do is we're going to go ahead and start talking about functions.
No, domain and range again.
Yeah, domain and range. And if you remember at the beginning of last school year, we started out talking about domain and range. Remember that?
Yes.
That's a long time ago. And so we're gonna go ahead and review elements. And this section today is we're gonna get through. We're not gonna get through all this today, so it might be today and tomorrow. I don't know. It'll just be how much time it takes.
Oh, I forgot my binder.
And there are videos that I have that show you this too. So I don't know if I'll. So a function from a set D to a set R is a rule of science. Every element D, unique element R. The set of D of all input values is domain of function. Set R of all output values is the range. And one thing I like to do, in fact, I brought this up during Wildcat time yesterday with the group we were working with. There's something that to help remind me. It's called Dixie-roid. Anybody ever heard of Dixie-roid? Yeah, it sounds like steroids. It's kind of weird, isn't it?
That's what Tatis took.
Yeah. So what it is, in fact, I'm going to do better if I write it up here in hand, because I just am able to do it a little bit.
No.
So this is sort of an acronym that helps you keep it straight what they are. So here, this D here
Everybody can use them.
stands for domain. This R stands for range. Okay? Domain range. This one, this I here stands for input.
Do this.
This O stands for output. Okay, this X just stands for X, this Y stands for Y, and this I stands for independent.
Oh.
Independent. And this D stands for dependent. So basically, domain, range, input, output, X, Y, independent, dependent. Isn't that kind of weird? Yeah, but that's one thing that can help keep things straight. So I was telling that to our Wildcat people yesterday. You don't want to erase?
If you look at it from one angle, the x and the i's make it look like it's an absolute value inside the x.
Oh, okay, yeah, it does. Yeah, it does look like it, doesn't it?
Yes.
What, Mr. G, what's X?
X,
It's like the X
the
variable.
letter X, X coordinate, Y coordinate, that's what that means. So it's just a matter of grouping, like this, like these would be like, these would be all one thing, this would be like the opposite pair of that. Okay. I'll leave that part up here from fourth period. Okay, and then sometimes you'll see this mapping, they call these potato mapping, sometimes you see this. You remember these things here?
Yeah.
Like you have what a function is. Here is a function, here is not a function. How would you like going to, have any of you gone to a vending machine and then you press something and the wrong thing comes out?
No. Yeah.
Because the person
They always give
might
me the
have
right thing.
might have stocked the wrong drink in there or something like that, probably. Well, that's what you don't want. A function is where the right button for Pepsi or Coke or whatever comes out like this, but the wrong one would be is you press a button and you don't know what you're gonna, you could get possibly different things from button press. So that's an example of what a function and not a function would look like. And then this example one, does the formula y equals x squared define y as a function of x? Is that a function? Is that what it is?
Mr. G, can you go back to one for like 2 seconds?
Does anybody notice something a little different about Touch TV today?
I've used it for the first time.
They got ray tracing?
No? There's one very subtle difference. We actually had the thing raised up a little bit yesterday during calculus class. It was a calculus class project. We raised it probably 1.5 inches.
That's a lot.
Yeah, it is.
Okay. Okay, next. Does the formula y equals x squared define y as a function of x?
No.
So
Yes.
you can test it. It has to be if you have like x, y, and if you put in a number for x, any number, 0, 0, but is it possible that I can press in 1 and get 1 here? And is there any real number I can put here on the left and not get only one possibility on the right side?
No.
No, there's not. So answer to this question is yes. But if we had the opposite case, if we had something like x equals y squared, would this be y as a function of x? No, it wouldn't, because what you'd have, when you solve for y, you would get y is equal to plus or minus square root of x. And that, therefore, this would not be a function. This would be a function. So just watch out for something like that. Because when you graph this one here, what is that going to look like? When you graph this one here, it's going to look something like this. Not a function. If you graph this one on the left, it's going to look like this, a function. Okay? And we are going to 19. Okay, we got another minute or so left. Okay, let's see where we are on this next one here. Yeah, okay, we'll just leave it. One of these graphs is not the graph of a function. Which one is not a function?
The far right one.
Far right one, because it fails the
Vertical line test.
vertical line test. So we are going to, so there it is, fails the vertical line test. What we're going to do
I don't have a notebook.
is, yeah, so we're going to just leave it there today and start work on this more tomorrow. Okay, thank you, ladies and gentlemen.
I have like a note folder.